In this video, I'm going to be talking about volume by cylindrical shells. So let's first look at an example similar to ones that we've been doing in previous sections, are volume by revolution. So we have find the volume formed by revolving the region, bounded by y equals 2x minus x, and the x-axis, all about the y-axis now. It'd be really easy if we were revolving this around the x-axis. But we're not. We're revolving it around the y-axis. So what we would have to do here is we have to look at this function and split it up into two functions. One function that's there and one function that's there. Because remember, we have to do pi integral of r squared dy. So let's talk about how we're going to solve for x for that function. So I have y equals 2x minus x squared. So I factor out a negative x, and I factor out a negative x correctly. Not a negative x, just a negative. X squared minus 2x. Now how we're going to solve for y is we're going to complete the square. I'm going to add 1 inside and subtract a negative 1 outside. That's because it's a negative 1 comes by that negative. Okay, so what we now have then is we have y equals negative x minus 1 squared plus 1. Solving for y, and I'm going to run out of room, and you could do this algebra. We get two functions. We get 1 plus or minus root 1 minus y. So there's a blue function. That blue function is 1 plus root 1 minus y. And then the red function is 1 minus root 1 minus y. Okay, so what we have is we have to do the blue radius, so 1 plus root 1 minus y squared, but then I have to subtract this red radius. So I have to subtract pi of 1 minus root 1 minus y. And then I was just making sure I had that right because my notes say something different. And so then we have to do all of that work. And I'm not going to lie, I cheated and used my calculator today during class. And we got 2.6666758, which I'm going to say is approximately 2.6 repeating times pi, and that is 8 pi over 3. So then we have to do, so that's a really complicated way to do it. I'm sorry, guys. Somebody was knocking at my door. It's a really complicated way to do that. There's a much easier way. Okay? So I have this area, and I take and I revolve that area around, and I get a figure that looks something like this here. Okay, so I'm taking this area and revolving it around, and I get a solid, I should say. Okay, and remember how we first started with all of these revolutions. Is we first started with these revolutions by looking at a single rectangle and taking and revolving a single rectangle around an area and getting some sort of value. Now, what if I have a bunch of different, ending up with like technically cylinders that we're revolving around, And then our cylinders, this distance gets so small that we just basically have a bunch of cylinders that we're adding together to find the area. So how we get that formula is this. Okay, volume of a cylinder is pi r squared h. But in this case, we really have two cylinders. We have a big cylinder, and I'm going to call that big R, and then we have a small cylinder. So the volume of my cylinder is going to be the big one, pi big R squared h, minus the small one, pi r squared h. Now, a few things we can factor out is a pi and an h, and I'm left with an r squared minus an r squared. Volume of my cylinder is pi h, r minus r, big R, plus r. Okay, now there's a little bit of a crazy math here. So the volume of the cylinder is not that crazy. So I have pi h, and I have r minus r. I'm going to take, and I'm going to say, I'm going to divide that by 2. So that's the average of those two radii. I can't just divide by 2. I'm going to multiply by 2 on the outside. So let's look and see what we have here. Okay, so we have 2 pi, and that's my height. And then I have this piece here, which is the thickness of our cylinder that we're revolving around. Okay, and then this here is the average radius. So said another way, volume of my cylinder is 2 pi, my height, that's a function value, the average radius, I'm going to put that here next, is an x value, because my average radius, that's going to be an x value, times by my thickness, that's going to be a dx. So what I'm really doing here is I'm really a delta x, technically. Technically, that's a delta x. But now you guys know where I'm going. So now I have a 2 pi times the integral of x, f of x, dx. And I'm going from like a to b in this case. So even though I'm revolving around the y-axis, everything is in terms of x. So here's an example, or here are the two formulas. So you may want to pause the video and write down these two formulas. Okay, volume around the y-axis, notice again, everything's in terms of x. Those are in terms of x. And then when we're revolving around the x-axis, everything is in terms of y. Okay, so again, pause the video, write those down. So let's revisit example 1 and maybe being able to do this a little bit easier of a way. Okay, so let's look at this. Our formula is 2 pi integral. I'm going from 0 to 2 of x times by my function 2x minus x squared dx. Now it's a matter of just doing the calculus, doing like, really it's just the algebra. Distribute that through, by that I mean the x, And then I have 2/3 x to the third minus 1/4 x to the fourth from 0 to 2. So I have 2 pi, 2/3, 2 to the third minus 1/4, 2 to the fourth. And that all simplifies to 2/4. I have a 16 over a 3 minus a 4. Again, I don't know why I'm showing so much work. So that turns into an 8 pi over 3. Okay, which, again, going back, that's what we got on this first slide. Okay, and again, what we're doing is we're summing up a bunch of cylinders. How I can remember that formula? Basically, I have one cylinder here. What's that circumference? The circumference of the cylinder is 2 pi r, and it has a certain height to it, 2 pi. Our r is x. My height is f of x. That's how I remember the formula. Anyway, okay. One example done. Another example. Find the volume of the solid. Revolution of the solid revolves around, divided by that, around the x-axis. So again, okay, so I basically have one cylinder here. And what I'm doing is I'm revolving that around and around the y-axis, and I'm summing all of those up. So I have 2 pi, my radius, which instead of writing r, I'm going to write x, times by my function value, or my function, and then I'm going from 0 to 1. So I have an x squared minus an x to the fourth dx. I integrate. Okay, and integrating all that, I'm not going to show all of the work. We get 4 pi over 15 because that's kind of boring. I'm not even quite sure how long this video is. Okay, last example. So find the volume when I'm bounded about the x-axis. So I have here now this radius. I'll draw one that's a little bit closer. I'll take away that one. Okay, so that's again going to be a cylinder that revolves around, and that's my radius. Okay, so my radius is now y. So 2 pi integral of y, and what's my height? My height is 4y squared minus y to the third dy, and I'm going from 0 to 4. Okay, so again, going through this, I'm not going to kind of bore you guys. I'm going to go a little bit in the steps. 4y to the third minus y to the fourth dy, and then I'm going to integrate, and I'm going to get y to the fourth minus 1/5 y to the fifth, going from 0 to 4. And I'm just going to magically get us the answer. My guys confirmed with me today during class. That is the answer. You could do the algebra. We're in algebra 1. You need help with that? There you go. Okay, so that's our video on volume by cylindrical shells.